Hi, we're going to talk about number sequences today, and if you need more information on this and more examples, you can read Chapter 5, Section 7 from your textbook on MyMathLab. If you take a look at what sequences are, it's a list of numbers that follow a rule or a pattern, and the numbers in the list are called the terms of the sequence, and we often name the terms A sub 1, A sub 2, A sub 3, etc. I'm saying the word sub as in subscript. So when you see A sub 1, that means the first term in a sequence. When you see A sub 2, that means the second term in a sequence, etc. And the two main types of sequences we're going to be talking about today are arithmetic sequences. I know it looks like the word arithmetic, but it's pronounced arithmetic, and then geometric sequences. If we have time, we'll talk a little bit about Fibonacci sequences also. Alright, here's three examples of sequences. I'm going to give you a few seconds to look at the first one. You'll probably notice on the arithmetic sequence that we have an initial value, or our first term is 1, and then each term after that differs by 3, so it has a common difference of 3. The second one, the geometric sequence, starts with a first term of 2 and a second term of 6, etc. And you might notice that to get from one term to the next you multiply by 3. So that's a common ratio of 3. And then the Fibonacci sequence is a little tougher to figure out. What you do is you add these two. 1 plus 1 gives us 2. And then you add these two right here. 1 plus 2 gives us 3. In other words, you add the two preceding terms to get the next term. 2 plus 3 is 5, 3 plus 5 is 8, etc. And Fibonacci sequences have some really neat, if you Google that, you'll see some really cool things in nature that deal with Fibonacci sequence. Okay, here's some terminology for you. An arithmetic sequence is a sequence in which each term after the first term differs from the preceding term by a fixed constant amount called the common difference of the sequence. Now that sounds complicated, but it's not. All they're saying on an arithmetic sequence, we have a common difference, and that common difference just is how much do we add each time to get from one term to the next. So on this one, our common difference is 3. And then we have a formula to find any term in the sequence. So if I wanted to find the 10th term of a sequence, I'd use this formula right here. To find the 20th term, I'd use that formula. To find the nth term, I'd find this formula, use this formula with n, meaning what number are we looking for. So, whoops, what happened to my screen there? There we go. Okay, now I'm trying to get my pen to work here. So when you look at this formula, what it means is A sub n means whatever term we're looking for. So if you saw like an A sub 10, that means we're looking for the 10th term. The A sub 1 means the first term of the sequence. The D is the common difference. How much are we adding each time? And the N stands for the term you're looking for, which is, in this case, 10 in my example I just used. Now this might seem complicated. As soon as you see an example or two, it'll seem real easy. So let's use the formula. Let's take a look at this sequence here and then use the formula to find the 8th term of this sequence. In other words, find A sub 8. Well, if you look at the sequence up there, you'll notice that it differs by 3 each time. So the common difference is 3. So D equals 3. You'll notice the first term is 2, so A sub 1 is 2. And like I said, we're trying to find the 8th term, so we're letting n equals 8. So here we go. A sub 8, which means let's find the 8th term. You simply put the first term, which is 2, plus the common difference, which is 3, times n minus 1. And in this case, n minus 1 is 8 minus 1, because of the fact we're looking for the 8th term. So that gives us 2 plus 3 times 7, which gives us 2 plus 21, which is 23. Now let's see if 23 is actually the right answer. Do you agree we'd go 8, 11, 14, 17, 20, 23, and here we go. First, second, third, fourth, fifth, sixth, seventh. The eighth term of this sequence was 23. I just wanted to show you that that formula makes sense. And if you read what I wrote down here, I bet it makes sense that you would start with 2 and then you would add 3 7 times. So here we go. We're starting with 2 and we're adding 3 7 times. In other words, we're taking 3 times 7, and that's where this formula comes from. Okay, if I'm going to get through all the slides I want to get through, I better hustle up here. Let's find the 40th term in this arithmetic sequence. So we're trying to find the 40th term, so n would be 40. If you look at that sequence, do you agree that we are subtracting 4 each time? Well, subtracting 4 is the same as adding negative 4, so the common difference is negative 4. And then a sub 1 means my first term, and my first term is 9. So we're going to put this information right here into this formula here, and we would have a sub 40, which simply tells me that we're looking for our 40th term, is a sub 1, which is 9, plus my common difference of a negative 4, times n minus 1. Once again, n minus 1 is 40 minus 1 because we're looking for the 40th term. So that gives us 9 plus negative 4 times 39, and let's grab our calculator really quick. We'll take 9 plus negative 4, and then we're supposed to take that times 39. Okay, we get negative 147. So our 40th term is a negative 147. So you can see that using this formula is fairly simple. If you need to find a specific term in a sequence, you just use this formula. You can also add up all the terms in an arithmetic sequence by using the formula right here. So if I wanted to add up the first so many terms, in this case we're going to find the sum of the first 20 terms in this sequence. Well, if you look at that formula, notice we need to know a few things. We need to know the n, which means how many terms, which is 20 in this case. We need to know our first term, which is easy, but we also need to know a sub n, which in this case would be a sub 20, which means our 20th term. So before you can use this formula right here, we have to use the formula we just learned. Let's find our 20th term. A sub 20, remember how to do this? We take our first term, we add it to the common difference, which in this case is 6. We're adding 6 each time in this arithmetic sequence, times n minus 1, and we're looking for our 20th term, so that's 20 minus 1. Well, when you take 2 plus 6 times 19, that gives us 116. Now, I want to make sure you understand, all that tells us is our 20th term is 116. So now let's use the formula to find the sum of the first 20 terms. So I'm going to use this formula right up here. So s of, instead of writing s of n, I write s of 20 because I'm looking for the 20th term. So s sub 20 is our 20th, the sum of our first 20 terms, is going to be n over 2. Well, n is 20 divided by 2, times a sub 1, simply means my first term, plus a sub n is now a sub 20, and a sub 20 was 116. Remember, we found out that our 20th term was 116. Okay, that gives us 10 times 118, which gives us 1,180. So if we extended this sequence right here all the way out to the 20th term and added them all up, we would get 1,180. Now, to help you understand this formula, think of adding up the first 40 numbers, first 40 counting numbers, 1, 2, 3, 4, 5, all the way up to 38, 39, 40, etc. So, here we go. I bet you agree we could do that with a calculator, and it'd take a while, but we'd get it right. But there's a quicker way. What we can do is this. Let's add up our 1 and our 40, and that gives us 41. Now let's add up our 2 and our 39. That also gives us 41. We can add up our 3 and our 38. That also gives us 41. And you would keep doing that, and if you think about it, you would have to do that how many times? I hope you're thinking 20, because there's going to be 20 pairs of 41. Well, that's where that n over 2 comes from, and then our a sub 1 plus our a sub, in this case 40, comes from. So that's where this formula right here comes from, is just kind of using that example I showed you. Okay, let's find the first 36 terms in the sequence 10, 12, 14, etc. Well, it's definitely an arithmetic sequence, so we're going to go use this formula first to find the 36th term. So a sub 36 is going to be 10 plus 2 times 36 minus 1. And when we work that out, we get 80. So we know that our 36th term is 80. Now let's use this to find the sum of the first 36 terms. So s sub 36 is 36 over 2, because remember 36 is our n, times a sub 1, which is 10, plus a sub 36, which we found out was 80. Our 36th term was 80. And that gives us 18 times 90. So the sum of those first 36 terms, it would be 1,620. Okay, now there's two more formulas we're going to learn today, and they deal with the geometric sequences. And the two formulas are right here. This helps us find the term in a geometric sequence, and this one helps us find the sum of the terms in a geometric sequence. And instead of a geometric sequence having a common difference, it has a common ratio. That's what the R is right here. The R is the common ratio. And these are actually really easy, and you just use your calculator to help you. So here we go. Let's find the sum, let's find the 8th term of this sequence right here, 2, 6, 18. Well, the reason you know it's geometric is because we're not adding a certain number each time, we're multiplying by 3 each time. So we simply, to find the 8th term, we take a sub 8 equals 2 times the common ratio. So a1 is my first term, r is my common ratio, which is 3, to the power of n minus 1. Well, we want to find the 8th term, so I put an 8 minus 1 up here. So I have to take 2 times 3 to the 7th power. So I simply grab my calculator, and I go 2 times 3 to the power of 7. And that gives me 4,374. 4,374. Time's running out on me, guys, so I'm going to get to this last one right here. To find the sum of the first 8 terms. So now we're not finding the 8th term, we're finding the sum of the first 8 terms. You use this formula. So the sum of the first 8 terms is our first term times 1 minus the common ratio to 8. That came from right up here, over 1 minus the common ratio. So at that point, you let your calculator do the work, and it looks like I'm going to have enough time to do this. We go 2 times parenthesis 1 minus 3 to the 8th power. Okay, and that gives me negative 13,120. Then I have to divide that by 1 minus 3, which is a negative 2. So divided by negative 2. So if I added up all the terms, all 8 terms, I would get that answer. And I'm sorry, I think it was 6,560. Yeah, 6,560 is what we would get. So the two formulas you'll use for geometric sequences, which means we're multiplying by a number each time, are the two right here. And the two formulas you use for arithmetic sequences, which is when they have a common difference, not a common ratio, are found there and then here. Whoops. I know it's here somewhere. There we go.